Hello, my name is NURUL BINTI. I'm from CFAP1261B, Group 2.
Hi, I'm VALERIE JASMINE ANAK from CFAP1261B, Group 2.
Hi, my name is DEXTER. I'm from AP1261B, Group 2.
Hi, my name is JAKSON from CFAP1261B, Group 2.
I'm going to start the presentation with the introduction to self-compacting concrete. So what is self-compacting concrete? Self-compacting concrete is a type of fresh concrete that is specially formulated to flow and spread effortlessly into the formwork, filling every nook and cranny or any gap without the need to undergo external vibration for compaction. This concrete is ideal for consolidating concrete in construction when traditional vibrators are not feasible. Self-compacting concrete has filling and passing ability as well as segregation resistance. Lastly, for the introduction, self-compacting concrete flows well, compact itself, and consolidates materials without any segregation issues. So that's it with the introduction. Now I'm going to pass the slide to Dexter.
Thank you, Valerie. So, the history and developments of SCC. The Japan Society of Civil Engineers (JSC) has played a significant role in development and refinement of flowable concrete (SCC) since the mid-1990s. SCC was introduced in Japan during the late 1980s with the aim of reducing the dependence on worker skills. In 1994, the Japan Society of Civil Engineers released the first guidance documents on SCC, and the International Unions of Laboratory and Expert in Construction Material, System and Structure (RILAMS) produced reports on its mechanical properties. The American Concrete Institute published a comprehensive guidelines in 2007, which is currently undergoing revisions. Researchers and professionals, engineers worldwide have made a notable contributions to SCC technology. Next, I will move the slides to Jackson.
Why self-compacting concrete? First, the current concrete has been criticized for its lower strength and inconsistent quality. Second, there's a need for skilled workers to perform compactions in conventional concrete. Last, it is challenging to use mechanical compactions for underwater concrete, gas in situ power foundations, and column with congested reinforcement. Requirements for self-compacting concrete. There are three requirements for self-compacting concrete, which are filling ability, passing ability, segregation resistance. So in self-compacting concrete, it should have low cost aggregate content, increased pass content, low water powder ratio, increased superplasticizer dosage, and viscosity modifying agents. For material selections, the first material is cement. Portland cement is a vital ingredient in concrete. By adding supplementary materials such as fly ash, silica, fuel, or slag, the concrete can be fortified and strengthened. Second is aggregates. Portland cement is a fundamental ingredient in concrete. Incorporating supplementary materials such as fly ash, silica, fuel, or slag can enhance the performance and strength of the concrete. Third one is water. To achieve the best result, it is recommended to mix the concrete with clean water by maintaining the right water-cement ratio. This ensures that the concrete has the optimal flowability without compromising its strength. Next is chemical admixtures. Chemical admixtures are commonly used in constructions to improve the properties of concrete. These admixtures can include water reducers, set retarders, accelerators, air entraining agents, and superplasticizer. Lastly, mineral admixtures. Mineral admixtures such as fly ash, silica fuel, and slag are commonly used in concrete to improve its workability, decrease the amount of cement used, and increase its resistance to thermal cracking, alkali aggregate expansions, and sulfate attack. These admixtures are added in larger amount to achieve these benefits.
From Jackson explanations, I also like to add this point that is essential for the material selection. SCC can be distinguished by three ways, which are powder type, viscosity modifying agent type, and combined type. As for the powder types, SCC can be distinguished by adding more powder content to the mixture. Then, for the viscosity modifying agent type, the SCC can be distinguished by increasing the amount of viscosity modifying agent X mixture into the mixture. Last but not least, for the combined type, increasing the amount of powder content and using the viscosity modifying agent to the mixture can also distinguish the mixture of SCC.
Next is the mixing principle of self-compacting concrete. Self-compacting concrete is a type of concrete that does not require significant mechanical effort to form and place. The mix design of SCC must follow certain practice to achieve a high quality and durable end product. Before using the mix in constructions, testing it to meet the requirement is crucial. So, researchers have established guidelines for mixture proportioning of SCC to ensure an appropriate balance between the formability and stability, which is number one, high volume of paste. As SCC concrete undergoes self-compaction by its weight, it has to attain adequate filling ability so that the mix reaches every area. Frictions between the aggregates restrict this spreading and hence the filling ability. This issue is solved by increasing the paste content in the SCC mix design in a range of 300 to 400 cubic meter. The volume of paste implies the combinations of cement, water, and air. This increase in paste helps the separations of aggregates and easy movements of the mix. Number two, high volume of fines. SCC concrete should have sufficient workability without segregations or bleeding issues. To limit risk, it should have a large number of fines, with a sum replaced by pozzolanes or mineral exmixture, and strength and durability of the mix determine the volume of filler fines. Number three, a high dosage of superplasticizer is added to SCC to make it more workable and fluid. However, a high dosage close to saturation can make the concrete more prone to segregations. Superplasticizer will increase workability without causing segregations or bleeding problems. Number four, use of, use of viscosity modifying agent. When producing an SCC mixed viscosity modifying agent help in achieving flowability without causing segregation or bleeding problems. This thickening and water holding. So next is the flow chart for achieving self-compatibility. So what do we gain from this research? From this research, the first thing is reducing the water to binder ratio and limitation of coarse aggregate content can cause a high segregation resistance of mortar and concrete. Second one is if we addition of mineral mixture and usage of super plasticizer and VMA, it can cause a high deformability of mortar and concrete. So in these both things, which is a high segregations and high deformability of mortar and concrete, it can achieve a higher self-compatibility.
Now I am going to proceed with the slide with the test method for compactability for self-compacting concrete. Test method for compactability. These following are the test method done for the self-compacting concrete to check the compactability. Although many test methods have been developed for SCC, none of it have been standardized and the tests are not perfected. Firstly, for the filling ability, slump flow test, T50 cm slump flow test, and V funnel test are done to check the workability of the concrete, whether it is suitable to be used for the construction. As for the passing ability, J-ring test, U-box, L-box, other method done to verify the concrete flowing capacity over the form bypassing through the concrete reinforcement without segregation or outflow obstruction occurrence. Last but not least, the tests done for the segregation potential are settlement column test, sieve stability test, penetration test. These tests are done to check the risk of segregation. Now, I will pass the slide to Amira so that she can proceed with the presentation.
Thank you, Valerie. Now I am going to explain the differences between the SEC and the normal cement concrete. So the differences between self-compacting concrete with normal cement concrete. For the first aspect is for compaction for normal cement concrete, it is requires external vibration from compaction, while self-compacting concrete is self-levels and flows on its own. Secondly, voids and honeycombing for normal cement concrete is more, while self-compacting concrete is reduce the risk of honeycombing and voids. Thirdly, the construction speed for normal cement concrete is slower due to compaction requirements, while self-compacting concrete is faster construction due to self-leveling. Next aspect is noise and vibration for normal cement concrete is generates noise and vibration during compaction, while self-compacting concrete reduces noise and vibration on site. Lastly is mix design and testing. For the normal cement concrete, it is standard mixed design and less complexity, while self-compacting concrete is complex mixed design and vigorous testing. Now, let me proceed with the application of self-compacting concrete in the next slide. Continuing from the previous slide. Now, I will explain to you about the application of self-compacting concrete. Firstly, self-compacting concrete is used for casting heavily reinforced sections, places, and buildings. Besides that, self-compacting concrete also have the ability to flow and fill formwork without the need for vibration. Furthermore, it is also being used for bridge construction and other infrastructure projects. Not to mention, the flowability and passing ability are useful for filling intricate formwork and compact reinforcement. In architecture, self-compacting concrete are used structures with complex designs and shapes. Moreover, the ability to flow and fill complex molds without segregation. Self-compacting concrete is also used in the production of precast concrete elements, including panels, beams, and columns. Self-leveling ability ensures that precast elements are well combined. Lastly, from our research, self-compacting concrete are also used to reduce noise and vibration during the construction process. The absence of external vibration equipment make it quieter. So, by these following applications, we can say that we have a lot of advantages from the self-compacting concrete. Without any further ado, let me explain to you the advantages of the self-compacting concrete. Now, I'm going to explain the advantages of self-compacting concrete. Self-compacting concrete offers several advantages in construction. Firstly, it reduces the labor required during the concrete testament process. Besides that, noise and vibration levels during the construction process are reduced. Next, exhibits excellent workability, making it easier to pump, and there are many placement techniques available. Furthermore, creates smoother and more aesthetic surface finishes. And lastly, self-compacting concrete improve durability, strength, and reliability, and also minimize voids in highly reinforced areas. Now I'm going to pass the slide back to Valerie so she can explain the disadvantages of self-compacting concrete.
Thank you, Amira, for explaining the advantages for self-compacting concrete. Now, let me take over the slide to explain the disadvantages of self-compacting concrete. Disadvantages of self-compacting concrete. Self-compacting concrete faces the following limitation in construction, which means it may result in a greater shrinkage and creep due to higher paste volume. Besides that, more trial batches are required so that the right mix can be obtained. Next, self-compacting concrete also costs more than conventional concrete based on materials, except for placement costs. Lastly, the disadvantages are the mixed design and procedure being used are too complex for practical implementation. Now, let me proceed with the slide with the conclusion for our topic. After going through on our research from this topic regarding self-compacting concrete, what can we conclude is self-compacting concrete is a type of freshly made concrete that is designed to flow and spread easily without the need for external vibration. It is an ideal solution for projects that require efficient and high quality finishing. Besides that, concrete placements such as heavily reinforced sections, buildings, infrastructures, and architectural structures with complex design and shape could also be placed more easily. The use of self-compacting concrete can also reduce noise and vibration during the construction process while minimizing the labor required for concrete placement. Last but not least, this innovative solution is widely used in the production of precast concrete elements like panel, beams, and columns. Overall, self-compacting concrete is an effective and reliable option for various construction projects that require precise and effortless concrete placement. That's it with our presentation. Without any further ado, I'm going to express our gratitude with a video that is going to be shown after this. Thank you for the attention given.